how many 8-digit passwords start with 997 or end with 01. We're going to make a few notes about this problem first. First of all, we need to know that possible, are digits from 0. So basically, we have 10 possible digits to choose from for every place in the 8th ring password. We know the magnitude but the size is 8 digits long. We know that we are allowed what we call, because our outlines to us that these 8 strings needn't be distinct, right? They don't have to be distinct. Now it gives us a constraint. Let's look at the constraint. Well, it's not really a constraint, it's more of a specification. We want to find how many passwords we have that end with 99. Was it end or start? Okay, sorry. End with 01 or start with 99. Now, to solve this, we need to create some sort of general password, right? The general structure. Right, so to do that, we're going to create 8 slots. So here we'll consider case where we have 997 being the first 3 terms. So here we know that first 3 terms are 997. Since we know we're able to have repeating numbers and duplicates, we have 10 options here, 10 options here, 10 options here, and then 10 options here. So basically we have a total of 10 to the 5 options. So this 10 to the 5 accounts for all passwords that have a 997 at the beginning. Now let's consider case 2. Case 2 is when we know that these last 2 are 01, but we still have 10 possible choices for each of these 6 possible passwords that end with 0 and 1, right? And again, we do 10 here because we have 10 up to these 6 possible passwords that end with 0. And again, we do 10 here because we have 10 options for each of these slots, right? If you imagine these as sort of empty slots that have not determined what they want to be. Let's say these are like 10 different or 8 different people, and these different people have sort of 8 jobs or 10 jobs, that they can choose from. Then each of these boxes have 10 possible roles that they can take state of or they can realize to themselves. So here we'd have 10 to the 5 plus 10 to the 6 possible passwords. That counts for when it starts with a 997 and ends with a 01. Now, this would be the end of the problem if we had not accounted for another little piece of we have an inclusive as indicated here. So where does it tell us that? It tells us that, well, first of all, it asks us for how many 8-digit passwords start with a 997 or end with a 01, right? This or is inclusive. They make clear to us that it's inclusive. What does that mean? Not only does that mean you have to consider both cases and take the sum of them, which means you're considering cases where it's either this or that, but you also have to consider the case where there's both, right? So there's a special third case here that we can consider, case 3, where we're considering when it ends or starts with a 997 and ends with a 01. So that means starts with 997, ends with 01, and we have left these 3 slots that can be one of 10 possible digits. So basically what we have here is, if you had not accounted for this third case, we'd be missing a 10 to the 3 possible password configurations. Right? So that's when you pay attention to the wording. If this had been an exclusive or, then we're only considering cases where it's either starting with the 997 or ending with the 01, but not both. That's the exclusive or. But we're considering all 3 cases with an inclusive or. So again, third specification is that can also be both, right? Can both start with 997 and end with 01. Now, something else that might immediately come to your head is that you might have just instead thought of all possible passwords and then subtracted from some special amount. So you might have used the subtraction principle. That might not be the best way, Because here we've only done 3 calculations and already found the answer. In terms of that sort of subtraction idea, we find, let's say 10 to the 8 is all possible passwords. All possible passwords. And you want to subtract 10 to the 8 by some x value. And this x value will be considering all passwords that don't fit into this consideration or these constraints. I have another problem that's not necessary to be solved. You can directly solve this problem with no additional hassle or no additional calculations beside what is immediately clear. So if ever a problem is posed like that, it's recommended to just do the problem and not find a similar or equivalent problem. Now, another thing I can add, another note, if these had not been necessarily distinct, so we could say distinct, if that had been the case, then what we'd have here is that a decrease in sequence, because each choice of a single digit decreases the total number of options the next consecutive placeholder has. So if this had been non-distinct, distinct values, then it'd be decreasing this. So this would not be 10 factorial, or this would not be 10 to the power 6, it would be 10 factorial over 10 minus, which is the same as p 10. So just be careful with the wording and know what it actually, hopefully that helps. Now, an issue with this problem here, when we consider case 1 and case 2, we are counting all possible situations, these non-distinct choices or non-distinct values for passwords that start with a 997 or end with a, but the issue is that both case 1 and case 2 sort of overcount, and the sum of both of them overcount even more, because within this count of 997 with some variation of the endings, there exists a couple of situations where it ends with 0-1, because if it ends with 0-1, then we still have some situations here that we can choose from. So if the situation where it starts with 997 overcounts passwords that end with 0-1 and the same occurs with 0-1, then what we have to do instead is count case 3, which is 10 to 3 passwords, subtract our total amount. Because what happens is we end up overcounting or double counting some of these instances where case 1 and case 2 overcount for each other. So this borrows from which is formally written as the magnitude of A plus the magnitude of B minus those that are common between A and B is equal to that's the total. That's what the subtraction tells us. These are the total distinct, or these are the total number of values that fit or within a constraint, and these are the overcounted values. So if you think of a set, what you'd have here is you're looking for these distinct values in each of those sets, and you're subtracting away, and these overcounted values don't have. So that's why here you would subtract instead of adding them. Adding them would basically triple or quadruple count these additional instances, but it is sufficient to consider case 1 and case 2 and then subtract case 3, because case 1 and case 2 sort of overcount for each other. Because again, if I were to specify 997 must begin this password, then at some point, I'd be randomizing these passwords. At some point, I'd reach the endings are 0-1, have the option to be whatever they want. And the same occurs when this ends with 0-1, but can start with whatever it wants. So it'll cycle through all the numbers until it gets to 997, and then it still has the choice of these middle. So these middle portions can cycle through whatever they want to be, but they share the commonality of the starting and ending. And this case 3 accounts for those, and then you subtract from it to get those distinct, unique passwords, not the duplicate passwords. Because it asks here how many 8-digit passwords start with that or end with that. Now, if that were not the case, if this was the exclusive or instead, then the problem will change slightly. Let's see how it would change actually. So in terms of the exclusive OR, what we would do is we do case 1, right? Case 1 the same, but then our distinction comes, case 1 and case 2 run the same way. But when it comes to considering case 3, we have the notion that we do not consider it at all. So case 3 is entirely ignored. And that is because for the exclusive OR, we don't want any password to satisfy both conditions. So we don't want to make any adjustments for the overlap, because those passwords are not included in the count at all. So if the exclusive OR, you would simply add both values from case 1 and case 2, and thus you would allow yourself to have all possible values that have either start itself with 997 or end with. And now the basic idea behind that, because the exclusive OR true when you have A and not B, or not A and B, right? So when we exclude this value from our exclusive OR calculation, our exclusive OR total, all that we are doing is